When you first start lifting weights, you can become noticeably stronger before your muscles even look bigger. So where does that extra strength come from? It starts with your brain. Every movement begins when your nervous system sends electrical signals to your muscles. Your muscles contain groups of fibers controlled by nerves, known as motor units. When you are new to an exercise, your body is not very efficient at using them. It may activate too few muscle fibers, fire them at the wrong time, or waste energy by tightening muscles that oppose the movement. But each time you repeat the exercise, your nervous system gets better at controlling it. It learns to activate more motor units, make them fire faster, and coordinate the different muscles involved in the movement. This is why beginners can become stronger within their first few weeks, even if their muscles have not grown very much. Their body is learning how to use the muscle it already has. Think of it like upgrading the software before upgrading the hardware. But eventually, better coordination is not enough. To keep getting stronger, the muscles themselves must adapt. When you lift something heavy, your muscle fibers experience mechanical tension. Your body recognizes that the current muscle is being asked to produce more force than it is used to. That tension activates chemical signals inside the muscle cells. These signals increase muscle protein synthesis, which is the process of using amino acids from food to build and repair muscle proteins. Over time, more contractile proteins are added to the muscle fibers, making them thicker. This process is called muscle hypertrophy. A thicker muscle fiber can generally produce more force. People often say that lifting works by creating tiny tears in your muscles. Muscle damage can happen, especially after a new or unusually difficult workout, but tearing the muscle is not the main goal. The most important stimulus is tension. You do not need to destroy your muscles or feel extremely sore after every workout to become stronger. Your body also adapts outside the muscle. Tendons, which connect muscles to bones, can become stronger and better able to transfer force. Bones can respond to repeated loading by maintaining or increasing their strength. Stabilizing muscles also improve, helping you control heavier weights more safely. But the body only makes these changes when it has a reason to. This is where progressive overload comes in. Imagine that you lift the same 5-kilogram dumbbell for the same number of repetitions every week. At first, it may be difficult, but once your body adapts, that workout no longer presents much of a challenge. To continue improving, you must gradually increase the demand. That might mean lifting slightly more weight, completing another repetition, adding a set, improving your range of motion, or performing the exercise with better control. The increase does not have to be dramatic. Small improvements, repeated consistently, give your body a reason to keep adapting. The way you train also influences the kind of strength you develop. Heavier weights performed for fewer repetitions are especially effective for improving maximum strength because they force the nervous system to recruit a large number of muscle fibers at once. Moderate weights performed for more repetitions can create enough tension and training volume to build muscle. Even lighter weights can build muscle when the set becomes challenging enough, although heavier training is usually more efficient for developing the ability to lift very heavy objects. But the workout itself does not make you stronger immediately. A difficult workout actually causes temporary fatigue. Your muscles use energy, performance decreases, and the body must begin repairing itself. The improvement happens afterward. During recovery, your body rebuilds the stressed tissues and prepares them to handle a similar challenge more effectively in the future. That process requires enough food, particularly protein, because protein provides the amino acids used to build muscle tissue. Sleep also matters. Poor sleep can interfere with recovery, reduce training performance, and make it harder for the body to maintain and build muscle. This means training harder is not always better. If you constantly train without recovering, your performance may decline instead of improve. The goal is to apply enough stress to create adaptation, then allow enough recovery for that adaptation to happen. You also do not need the perfect workout plan, expensive machines, or complicated techniques. Barbells, dumbbells, resistance bands, machines, and bodyweight exercises can all make you stronger. What matters is that the exercise challenges your muscles, becomes gradually harder, and is performed consistently. So lifting weights makes you stronger through several changes happening together. First, your nervous system learns to use your existing muscles more effectively. Then your muscle fibers grow thicker and gain the ability to produce more force. Your tendons, bones, coordination, and technique also adapt to the repeated demands. And progressive overload keeps the process moving by continually giving your body a new challenge. Strength is not created during one heroic workout. It is built through a repeating cycle. Challenge the body. Recover from the challenge. Adapt. Then return slightly more capable than before. Do that consistently, and weights that once felt impossible eventually become part of your warm-up.